There we go. And this is our official start of data structures for the semester. I hope you all had a great winter break. But we're going to have an even better semester. Data structures is, I think, the most fun class in computer science. And today I will give you a quick, high-level overview of why that is, some of the really cool things that we're going to be doing in this class. And then we'll have a chance to start talking a little bit about the actual material. But the really most important thing that we're going to do today is in the very last 15 or 20 minutes or so, you'll have a chance to log into this special Lambda server. You should have all gotten an email about the Lambda server with login instructions, and I want to make sure that you're all able to actually log into that to get the assignments done. So I'm going to share my screen now. And as I'm doing this, I just want to point out that if, as I'm talking, on Zoom, I sometimes have a tendency to talk a little bit fast. If you want me to repeat anything, feel free to just interrupt me. If you have questions, feel free to interrupt me. But also I have the chat, the Zoom chat open on a second monitor over here. So if you have a question, but it's not like an interrupt, ask it now sort of question, feel free to put it in the chat and I will get to it when it's a good stopping point. Okay, so data structures, CS46. On the screen over here, I have our course webpage opened up, and you notice that we're not going to be using Sakai for this class. We'll be using Sakai actually to manage the grades for this class, but the main content of this course and all the assignments, all the information about the course will be posted on GitHub. This is a tool that is widely used in industry and computer science, and I want to get you some familiarity with this tool, so that's why the course is hosted on GitHub. And the way this is going to be structured is there's this issues tab up here at the top that if we click on that, this is where I'll be posting all the messages, announcements about the course. And I'll go over in a second details about this. And then up here every week in the course, I'll be posting the assignments for the week, and various lecture notes will just appear as a folder up here. You can click on that to visit it. So if you click this, it'll take us to our first week's course. And since this is a computer science course and computer scientists start counting at 0, you might think, your other professors might think this is week 1 of the semester, but this is actually in fact week 0 of our semester. So that's why it's week 0 up here. And then this main page has all of our syllabus on it. And at the top of all of these pages, I'm going to have some sort of fun link or comic. And if you click this, it'll take you to some information that's kind of about the culture of computer science in some way, or of programming. So SMBC is a very popular webcomic about algorithms and data structures and other things as well. But you can click on these things to get more background if you like. So about me, my name is Mike Isbicki. This is my 2nd year here teaching at CMC. I go by Mike, so please just call me Mike, not Professor Mike, not Professor Isbicki. Computer science is a very informal discipline. When you go out into the real world, you get a job, your boss is not going to ask you to call them by Mr. So-and-so or Dr. So-and-so. It's always just going to be, hey, my name's Mike, call me Mike. Nice to work with you. Everybody who works at Facebook, for example, they don't talk about Mr. Zuckerberg, they talk about Mark. Nobody at Microsoft was talking about Mr. Gates, they were talking about Bill, and so on. My email address, feel free to email me about anything. Yeah, I guess my office isn't super important right now that we're on Zoom, but there it is. We'll have office hours immediately after class every week, or if for whatever reason those don't work for you, happy to take appointments. Just send me an email and we'll set something up. Okay, so some fun facts. So I grew up in San Clemente, so pretty close here to Claremont, Southern California. Spent 7 years in the Navy, but then wanted to come back home to California. So I went to UC Riverside for PhD and postdoc. But then I left again to go to North Korea for 2 semesters to teach abroad. And this was part of a program to help improve relations between the United States and North Korea by having ordinary people from both countries interact with each other. One of my takeaway experiences from the Navy was that war is actually really bad and we should avoid it. And so I try to do things like this to help us prevent those wars from happening in the future. Something that's maybe a little bit more relevant to our class this semester is that my wife's currently pregnant, and sometime mid-semester, depending on when the baby decides to come, I'll be having a baby, and that may involve shifting around the class schedule a little bit, probably late May, early April if that happens. But I think it should mostly be a smooth transition and minimal interruptions. So now about the course, data structures. This picture right here is sort of my map of what computer science looks like at CMC, or at least the classes I teach. And so the first intro class, CS40, my idea of that class, and this is the same if you took, say, CS5 at MUD or intro at Pomona or one of the other colleges. But my idea of this class, this intro class, is that you're just working on one computer, just your laptop, say, and writing code that works for you. In this course, though, CS46, we're going to start working not just on your computers, but also on remote computers as well. And in this setup, that's going to require us to learn a lot of new technologies. So things that you may or may not have heard of before are bash scripting, Git and GitHub. So again, our whole class is hosted on GitHub here to help get you that familiarity with it. Then these other techniques called continuous integration and Vim and parallel computing. And these are things that are not necessarily always covered in data structures courses. So these are things that if you take this version of data structures, CS46, you'll have exposure to this, but you may not get that exposure if you were doing it say at MUD or at Pomona. The main sort of purpose of this course is to kind of bridge the gap between CS40 here and CS143, which is the big data course at CMC. And this is, the big data course is like the culminating computer science course for the data science major that we just introduced. And in this data science course, you'll be working on not just one remote server, but hundreds or thousands of millions of remote servers at a time. And how do you coordinate all of those remote servers together? So it turns out that everything that we will do in this course, the techniques that we'll use, there are other techniques for working with remote servers that are maybe a little bit easier and you'll hear students in other courses using, but we're not going to use those because they don't transfer over to this thousands of remote servers scenario. And I'm going to force you to use a lot of tools like this tool Vim right here. You'll get very familiar with Vim. Some of you will love it, some of you will hate it. And the purpose of that is so that when you go on to take the big data course, if you choose to, you'll be able to really hit the ground running in that course. So this data structures course, it's one of the foundational courses of computer science. Most people would say is the most important course in a computer science curriculum. And one of the reasons for that, there are many, but one of them is that when you go out and do interviews at companies like Google or Microsoft or Facebook, the sort of questions that they ask you to test your computer science knowledge largely come from this data structures course. And so if you do well in this course, you will be able to get great jobs at those companies. And those jobs pay a lot of money. So one of the things that I like to do is on all my computer science courses is explain or show you how much money you can make if you choose to make this a career. This levels.fyi site is one of the probably most popular sites for computer engineers, data scientists, all of these sort of technical roles to share salary information with each other. And so here we'll look at Google's entry-level salary right here. L3 is the entry-level position at Google. L1 and L2 are for like intern level positions. And so L3 is a new graduate from college. And this is a typical salary for an L3 working at Google, $188,000. People who are L3 have typically been working at Google for anywhere from say 1 to 5 years. And so when you're first getting hired at Google, your salary probably wouldn't necessarily be this high, but after just a couple of years, you're in this range. And let's see, so I want to scroll down here to, they just have a bunch of examples posted. So here's a person working at Google in New York City. They just hired, fresh out of school, and never no experience before, $192,000. Here's a person, 2 years of experience working at Google, $245,000. And so on. You can look through this as much as you'd like on your own time compared to other companies, but you'll see that the salaries are in general pretty good. And another thing that I like to point out is those salaries are great even though tech employers are illegally colluding to reduce your salaries. So my prediction is that over the next 5 to 10 years, when you all are getting into the market, those salaries are just going to be going up. Okay, so who should take this course? So one of the nice things about the Claremont colleges is that you get to take courses at all of the other colleges, but especially in computer science, I think that can be a little bit confusing for students of figuring out which course is appropriate for you. So here's my guide about how to do that. So my expectation is that you've taken one computer science course so far. These are the sort of most common ones that people take, but there are other ones that you could have taken as well. Or it could have been off campus. Doesn't really matter where you took your first course. We're all kind of starting at the same level. Another thing is that if you've taken another data structures course, so Pomona currently has it as CS62, Harvey Mudd as CS60 or CS70. If you've taken one of these courses, you cannot get credit for this course. Right now, Scripps and Pitzer are both in the process of developing their own data structures courses. And so once those courses are developed, you will not be able to get credit for those courses as well if you take this course. And then the last thing is that this course is really designed for students who are in CMC's new data science major. So if that's your case, then perfect, you're in the right spot. If you are a computer science major, this is not the right spot for you. You cannot take this course. If you're wanting to do the computer science sequence or the data science sequence, then this is also a great spot for you. If you have any personal questions about like your own background or goals, I'd be happy to, in office hours after class today, talk with you in detail to see if this is the right class for you or if a different class would be more appropriate. Okay, so what are we going to cover in this class, our learning objectives? So I want to start with the second objective here because this is sort of the standard data structures. Every data structures class is going to cover this. We're going to ask 3 questions about our code. The first is our code correct? So you've written a whole bunch of stuff. We want to actually be able to prove that our code is going to do what it's supposed to do. And this is a little bit different than proofs in mathematics, but we'll actually be able to prove stuff about our code. And you'll be doing that in this class. Actually, all of the grading in this class, we'll talk about that, but all of the grading is going to be along these lines of actually the automatic grading system will prove that your code is correct or incorrect in certain ways. The second question we want to ask is how many resources does my program consume? And there's a lot of different types of resources. The most famous one is time. How long does it take my program to run? And so that's where we're going to spend the most time talking about in this class. But other things are like, how much memory does my program consume? Or how much money does it cost to run my program? And those are potentially equally important, or maybe even more important in the case of money, since if you're a business, that's actually what you care about. And then the last part here is, can we do better? We'll see that there are situations where there is no better algorithm or data structure for accomplishing some given task that we want to do. And we'll talk about how can you even know that in principle? Like maybe 20 years from now, some super genius is going to invent something that's even better, but we'll be able to prove or talk about why in some situations we know that can't happen. So this is sort of the foundations of every data science, or sorry, every data structures course. And then one of the things that makes this course a little bit different than data structures at, say, Harvey Mudd or at Pomona, is that we're also going to be talking about these concepts right here. So DevOps stands for Developer Operations. This is sort of all of the things other than code that goes into getting a major website like Google to run. Like, how do you coordinate all of this code together? How do you work with different libraries? How do you create your own libraries for other people to use? We'll be talking about all of that in this class. We'll also be talking a lot in this class about open source software, how to use other people's open source software, and how to create your own open source software, and how to contribute to other people's open source software. Essentially, all of our assignments are going to be structured in the way that an open source project would be structured. So you'll have a lot of experience by the end of this course of working with open source software. And there's two reasons for that. One is that, so there's sort of an ideology around open source software of that, like, when you do something, we should want the whole world to benefit from it. So that's one part of it. But the other part is that all of these jobs, again, where you're making a lot of money, $188,000 a year as a starting salary, one of the ways that you get hired at these jobs is you have open source software that companies can look at and say, hey, I know this person can complete the tasks that I want them to because they've already done it in their open source code. And so by structuring this course around open source software, my hope and my experience from past students is that this gives you a leg up in these interviews to get the good jobs at these companies. Other things that we'll talk about, so this thing called shell programming. So it's most of this course is going to be done in Python, but we'll also be learning another programming language called Bash, which is what this shell programming is. Yeah, so you get your more experience with Python programming. So again, the sort of questions that the interviewers like to ask in interviews to test your knowledge of computer science, they all have their foundation in this course. So if you can't do the things that we're talking about in this course, then guaranteed you're not going to be able to get a good job at Google. This is another one of the things that I like to think about this course is that this is the course that sort of makes you employable as a computer scientist. That after you take this course, you can go on and get an internship at one of these companies. And so this is the second time that I've taught this course here at CMC, and this was the case last year that after students had taken this course, several of them went off and got internships at these companies. But it's also been my experience at other schools as well. Yeah, we'll talk about some of the math of programming and this idea of hacker culture as well, which is very intertwined with open source software. Some of the things that we won't do in this course that other data structures courses do are something called low-level memory management. So these are the sort of two famous languages for low-level memory management, C and C++. These are sort of languages that if you were a computer science major, very important for you to learn. But if you're a data science sort of person, then they're not very important at all. And so that's why we don't cover them in this course, since this course is geared really for the data science major. This course is also much more practical than the other courses. The other courses talk a lot about like theoretical things, but all of our stuff is tied directly back into applications in this course. The last course, or last thing that I want to highlight is this course right here, CS 148, Graph Algorithms. So this is taught by Professor Sarah Connor at CMC. And this is sort of the follow-on course to data structures that if you really want to master the interview for companies, it's this class plus the data structures class. You do those two things, you'll ace all your interviews. Any questions so far about sort of the contents of the course? I see there's a couple questions in the chat right now that I'll get to in a second. They're great questions, but hold on those. Anything about the content of the course or what to expect? Okay. So textbook-wise in this course, you don't need to purchase anything. All of our textbooks are free, both free as in beer and free as in speech. I invite you to click these links and learn about the history of these phrases, but they're closely intertwined with the open source philosophy of our course. Yeah, they're all open source. Everything in the course is open source. So the first one is a data structures, a textbook. All sort of the concepts will be coming from this textbook. And then we'll also be relying pretty heavily on the official Python documentation in this class that after you take this class, everything in the Python documentation will make sense to you. There will be no feature of the Python language that you haven't been exposed to. Okay, so now from a student's perspective, maybe the most interesting part, grades. How will we be doing grades in this course? Every week you'll have a weekly lab. So those labs are scheduled for Thursday mornings, and actual attendance at the labs is totally optional. Again, I realize that everybody's in sort of different time zones right now, and so it might not be practical for you to attend the lab live, and that's totally okay. But the concepts, the assignment part of the lab is something that you'll just have to complete on your own, and you'll still get full credit. The goal of the labs is that they should be fairly easy to do, just kind of step-by-step procedures for you to follow and complete them. So my hope is that everybody gets full credit on all of the labs. And then we'll also have weekly homeworks, which will be significantly more challenging than the labs, and they'll be worth anywhere from 10 to 25 points, depending on the week and the particular assignment and how challenging it is. For tests, there is no midterm in this class, but you will have one final. And that final will be just at the end of the semester. You'll have about a week to complete the final. It'll basically be just like a take-home sort of written assignment. My hope is that it should be a fairly low-stress endeavor, this final. And in total, so 250 points in the class after you add all this stuff together. No special categories for labs or homeworks or anything like that. How much time should you think about spending for this class? Well, historically, the typical student needs about 10 hours per week to get an A, including the, so we have, 4 hours of lecture and lab time. So then 6 hours on top of that is what you should expect for an average student. If maybe you struggled a little bit more in your intro programming class, or maybe the concepts in this class just don't come quite as easy as the intro class did for you, I still think getting an A is super realistic for you. My hope is that everybody in this class is able to get an A. What you would expect to do is just have to spend a little bit more time each week, especially on the programming assignments and on the debugging and working through those problems. My experience is that vast majority of students who are willing to spend between 15 to 20 hours per week on a data structures class, on this class, can get an A in the class. Yeah, the grades, standard grade chart right here, but there's one caveat, and that's that if you want to get any grade higher than an A- in this course, you must complete one of these two optional assignments. And these optional assignments are designed to get you a little bit more knowledge about sort of the culture of computer science. And so your optional tasks are to either watch these 2 documentaries right here or to read this, the first 3 chapters of this book right here. All of this is about the history of something called the Unix operating system. Unix is very closely related to open source, and this Lambda server that we'll be working on is an example of a Unix computer. And so, yeah, this is just designed to get you some of that background cultural information about computer science. The way that, yeah, there's sort of no grade based on this. You'll basically just tell me, I watched the videos or I read the chapters, and you'll get your A in the course. Any questions about grading? Anything along those lines? Okay. Let's see. Before talking about what the late work policy is and technology and collaboration policy is, we're going to talk a little bit more about the contents of the course and actually get started with some of the contents of the course today. And then a little bit later, once we're more familiar with the contents, it'll make sense what those policies are like. So in this course, we're going to spend the first about 2 weeks covering this sort of Unix and open source workflow, what it means to, or how you actually go through the mechanics of doing this. Normally, this course would have a 3-hour lab session, but we decided to make it just the normal hour and 15-minute lab session due to the online format and things. So it's okay with me if this Unix open source workflow stuff bleeds into this week. That's likely to happen, but that's okay. And then here's the sort of the main start of the actual data structures part right here. So algorithm analysis, you may have heard of big O notation before. This is where we talk about how long, can we prove how long it's going to take for our program to run. And then these are the sort of the main data structure section that we'll talk about: stacks and queues, recursion, and sorting, all key foundational topics. This part down here where we talk about trees, this is essentially like if you have a really large data set, say like gigabytes or terabytes or petabytes, how can you search that data super efficiently? And so it'll turn out that you can have petabytes of data. So Google has petabytes of data and search it in just milliseconds. And we'll be talking about in this section right here, how do you actually do that? And you'll be implementing yourself these systems for doing that. This section here on parallel algorithms, that's one of the things that's sort of unique to this data structure course. And I think it's going to be a really fun assignment that we get with this. You'll have a 4 terabyte Twitter data set about coronavirus, and you'll have to analyze it for figuring out how often do people talk about coronavirus over the past year, or how often do they talk about Trump or other topics like that. And you'll be using parallel algorithms to do that efficiently. Yeah, these last topics are also things that are not always taught in a data structures course, but really useful for the data science specific approach to data structures. So that's why they're in this course, may or may not be in other data structures courses. Any questions about anything high level about the course? Okay. So then we're gonna jump over here. Oh, actually, real quick. So since we were talking about grades, there's this EC folder, extra credit. There'll be a handful of extra credit opportunities throughout the course. I'll be posting them all through here. I really like extra credit, so feel free to get as much extra credit as you'd like right there. Okay, so week 0, today's week. First, let's talk about what the format of all of these week folders is going to look like. So again, at the top, there's going to be some fun comic that gets you insight into the world of Unix. And then there's going to be a section here, lecture, about like what are the things that we're going to talk about in this week. There'll also be a pre-lecture work section. And so this is something that I'm going to ask you to complete for Wednesday's class. So before coming to class on Wednesday, please watch this short video about what is Git and GitHub. It's just a 2-minute video. In general, all these pre-lecture work things that I assign should only be like 5 minutes max, nothing big. And then there's a bunch of cheat sheets right here that I'm going to ask you to print out. So cheat sheets for Bash and Vim and Git and GitHub. And by the end of our course, the end of the semester, the hope is that your all of these technologies are just like second nature to you. But at the very beginning, they will be incredibly weird, abstruse technologies. You will, if you don't say a lot of profanity when you're working with them, then you are a better person than I am, because I said a lot of bad things when I first learned these things. They're very frustrating. And those cheat sheets will help you out a lot, especially in lecture and lab as we go through those concepts. And then for labs, there'll be a lab section. And in general, in this course, labs will always be due on the Sunday of that week. So for this week's lab, you'll have until Sunday to complete it. And similarly for the homework for every week, it'll also be due on Sunday. There is one caveat to both of those two things, though, and that is that if you attend the class lab session, or if you're unable to do that, but you collaborate with another student in any way, then you get a 48-hour extension on both the lab and the homework assignment. So I really want to encourage you all to collaborate with each other, whether that's in the lab sessions or on your own. Please do that, and you'll get those extensions for doing that. Yeah, again, this week's lab and homework, they're sort of currently nominally due this Sunday, but probably extend that off a little bit more since it's just the first assignment. And then with the lab, there'll always also be pre-lab work. So this is stuff that I would like you to complete before the lab session, and then the actual instructions of the lab. The last important thing is up here, there will always be a homework link that takes you to your actual homework assignments. And so if you click that, it takes us to another page on GitHub, totally separate repository. And here is your instructions for this homework assignment. Basically, in this homework assignment, we're going to be learning about something called continuous integration. And this is a technique that we use to prove that our programs are correct by running tests on them, and GitHub will automatically run these tests for you and tell you whether your code is correct or not correct. There's this little red button right here that currently is red because the code's not correct, and when you fix it, it'll turn green. And when I'm grading, I'll see a green button here and just know to instantly give you full credit. But we'll talk about that, the details of how that works on Wednesday. Any questions about any of that so far? Okay, then we'll start talking about the actual material. So in particular, how to work on a remote Unix server. Start there. So the first thing that I'm going to do right now, I have my Firefox window opened up, and I'm going to switch over here to a terminal window. And if you're using either a Linux or a Mac machine, your terminal window will behave exactly like mine does here. And what we're going to do is do SSH into the Lambda server. If you are on a Windows machine, then there is a special program PuTTY that you need to download. There's a good question in the chat right now about there are multiple versions of PuTTY, a 32-bit and a 64-bit PuTTY version, and it's which one you should use will depend on your exact system. So if you have most people probably have a 64-bit computer, and so that would be the version to install and run. Once we have connected to the Lambda server, Then the very first time that you connect, it's going to ask you to change your password. And so you'll have to type in the original password that I gave you in the email, and then create some new password that will be your password. One of the important things in this class is that you do not share your password, you do not share your login credentials with anybody else. There will be times in this class where it would be really useful if you could do that, because it'll make collaborating with other people potentially easier, but it's also a major security violation and opens up lots of security vulnerabilities if you're sharing your passwords with people. And so in this class, it will be considered an academic integrity offense if I find out that you share your password with somebody else. So please don't do that. Once you're logged into this Lambda server, everybody's going to have the same exact computing environment. So it doesn't matter whether you're coming from Windows or whether you're coming from Mac or whether you're coming from Linux or whether you're coming from your iPhone or your Android phone. Once you're logged in, everybody's going to have the same exact computing environment. And that'll be really great, because it means that, yeah, we won't have any sort of issues with like, oh, I can't get this thing installed, get the compatibility for my version of Windows versus yours, or things like that. The downside is that you'll have to learn some of these new commands that you probably haven't seen before. And the first one, and the most important one, is called Vim. So VIM. And let's see, there's a whole big like history behind this Vim command, which we'll talk about a little bit throughout the course. But one of the key things to know about it is that it's a text editor for editing files. So Vim, and then the name of the file that I want to edit. So say just hello.py. And then I can do whatever I want, print hello world like this, and exit. And now in order to run my Python program, I would type Python 3, and then the name of my Python program, and it outputs it like this. So overall, sort of familiar environment that you might, or familiar set of steps that you might be familiar with, but the actual Vim command itself is going to be very, very confusing to everybody at first. And the reason that it's confusing is because Vim is what's called a modal text editor. So I'll type that out here. Vim is a modal text editor. And probably most of you have not used modal text editors before. And so what that means is that when you open up Vim and you start typing, those the things that you're typing don't directly appear on the screen. Instead, Vim is a set of commands, and you'll have to learn the Vim language in order to get your things that you're typing to appear on the screen. The way to do this, the way to learn the Vim language, is through a command called Vim Tutor, T-U-T-O-R. In Vim Tutor, you just type it in once you've logged into the Lambda server, hit enter, and it opens up this big set of instructions on how to go through and use Vim. And so before lab on Thursday, my request is that you all do this Vim Tutor command. But it'd be even better if you were to do it before class on Wednesday. Go through this Vim Tutor and start getting familiar with Vim. The instructions here say it'll take about 30 minutes. I found that it can take up to about an hour to work through this and learn the commands. So budget yourself an hour to do that. The most important command that you need to know, though, is how to exit Vim. There's a lot of jokes on the internet about somebody accidentally typed Vim in the terminal and they couldn't figure out how to exit, and so they've been stuck in Vim for centuries, or since 1970 when the universe began in the Unix world. And so the way to exit Vim, there are 3 things that you need to remember, 3 buttons to press. The first button is escape, the second button is colon, and then Q. So on my screen right here, I'm pressing escape. You can't see that, but I just pressed escape. Now I'm pressing the colon button on my keyboard. So you can see in the bottom left, the colon appeared down here. And now I'm typing Q, Q standing for quit, and then hit enter, and that's how you exit out of Vim. So that's the main thing to remember at this point. The one takeaway from this first lecture is how to exit Vim, escape, Q. Escape, Q. Let's see, there's a handful of good questions about connecting to the Lambda server in the chat right now. In about pretty soon, just 5 minutes, we'll give you a chance to ask those questions, and I'll ask everybody to try to connect. And we're definitely not going to end class today until everybody's been able to connect. But before we do that, are there any sort of big picture questions about this terminal environment and this Vim text editor? Okay. Yeah, so on class on Wednesday, we're going to really go into detail on this terminal environment and how to use it. We'll see lots of examples of commands and working with them. Before then, please try to run the Vim tutor command and log into the Lambda server. Right now, for those of you who, or right now, my task for all of you is to make sure that you can log into the Lambda server. And again, the instructions for how to do that with your account details, you should have received that in an email. But anybody who has questions, I will go ahead and start answering those to make sure that everybody can log in. Let's see, there we go. Let's see, so I'm just reading the chat messages right now. So there's a great question in the chat right now that when you are typing in your password into whether it's PuTTY or SSH, anytime you're typing in passwords on one of these terminal systems, the computer registers, it understands what you're typing in, but it will not display anything. So not only will it not display the actual letters that you're typing, it's not even going to display like an asterisk or something like that. It turns out that even just displaying asterisks, I would be able to, me as an expert computer hacker, I would be able to figure out what your password is just by the fact that it's displaying asterisks. So that's why it doesn't display anything at all. It's for security purposes. The other thing is that when you first log in, again, doesn't matter whether you're using PuTTY or SSH or any of these tools, it's going to ask you to change your password. And as part of that process, you're going to have to enter your original password in twice. So your original password when you log in, then it'll ask you to change your password. In order to change your password, you have to first enter your original password again, and then you can enter your new password. So you'll have to enter your original password, the one in the email, twice. So does anybody have questions, not able to get things working that you'd like my help with?
I do have a question.
Go ahead.
So I'm opening the PuTTY application and a new window labeled the PuTTY configuration opens and is asking for a host name.
Yeah, so the host name is the IP address. Okay. So it'll be 4 numbers separated by periods.
Okay, thank you.
You're welcome. Does anybody else have questions about getting connected?
Professor?
Mm-hmm.
I don't think I got the email for the login thing.
Yeah, so let's see. Let me go check on that.
Wait, maybe I did. Wait.
And was that Zach asking?
Oh yeah, I just found it. Sorry.
Okay.
Thank you.
Wait, can you quickly review again? I was having the same problem with entering the IP address. So what's the IP address again? It's the 4 numbers separated by periods that you send in the email.
Yeah, so it's in the email, it's number 134.173.191.241.
Okay.
That number. And then that's different than the port, which is the 5055 number.
Hi, Mike. So after we reset the password, it says connection to that IP address is closed. What's the next step after that?
Yeah, great question. So after you change your password, you'll have to reconnect and relog in using your new password, and then it should all work. You should come up with a screen where you can start typing those commands in.
So that initial thing that we did in like the SSH, and then the rest of that we type that out again.
Yep, just redo that same thing.
Professor, I can't find like where the terminal is in on Mac.
Let's see, I'm not a Mac user myself, but I think if you look at the Finder and just type in terminal, it should come up.
Professor Mike, I was wondering one question on just on the class in general in the extra credit assignments section. Do the extra credit assignments have due dates? Because they seem to be just
yeah, great question.
there.
So for all of the extra credits, it's as long as they at any point in the class, if you do those things, you get the extra credit for it.
Okay, awesome.
Mike, so I tried to exit the Vim tutorial and then type exit like that code, but it shows that there's nothing happened. Just say note if you're ever unsure about something you type, press exit to place.
Go ahead and share your screen so I can see what's happening. And yeah, press escape and then the colon and Q.
Escape, colon, Q.
I think you're pressing, that's the letter P instead of the letter Q.